Okay, let's talk about the Moody diagram here. So I have a picture here showing you the Moody diagram, and as you can see, on the left side of this is showing the friction factor. Oh, this one actually blocked the view, so let me just erase it. So on the left side, it shows the friction factor here. And on the very right side, it shows the relative roughness. How can I highlight this? Okay, let me see. So I'm going to bracket. So this is the left side, this is the friction factor. And then the right side shows the relative roughness. And then on the bottom, it shows the Reynolds number over here. So friction factor F is going to be used in Darcy's equation, and you can tell this F is dependent on this two-dimensionless factor, Reynolds number, and the relative roughness. You probably notice on the left side over here, the scale is not even. So this is actually a log scale. So F is on log scale. And also the Reynolds number on the bottom is on log scale as well. We discussed Reynolds number before. If you remember, Reynolds number smaller than 2000, which is for the laminar flow, and so the zoom on the left of this line here shows laminar zoom, and if you move up here and you can see the laminar flow, you only can find a straight line on this laminar flow zoom, and the F is only a function of Reynolds number, so you don't have to check the relative roughness when you calculate the friction factor for laminar flow. Okay, so when Reynolds number get into the range of 2000, in between 2000 and 4000, you're going to see something called a critical zoom. And in this critical zoom, you cannot even see any curves or line shows on this Moody diagram. And we said the characteristics of flow are not predictable. So as a designer, you probably want to avoid this zoom in your design. And when Reynolds number is larger than 4000, and we're getting into the turbulence zone. So from this red line on the right side of this red line shows the turbulence zone, and on the turbulence zone you can see a lot of curves over here, and these curves are generated from experimental data by Moody. So that's why this diagram is called the Moody diagram. I marked down the dashed line in the middle of this diagram here, and you see this orange line, and this is kind of the boundary here. So above this line, it is called a complete turbulence zone, or some book call it a fully turbulence zone. And as you can see here, on this fully turbulence zone, those curves actually turns into almost horizontal straight line here, which shows that in this zone, the friction factor F does not change much when the Reynolds number changes. So it's kind of a very steady number we can use later. Then below this orange dash line here, and this is actually the turbulence is not fully developed, and now what we can do is we have to check both the Reynolds number and the relative roughness to get a friction factor F. I want to mention one thing here, something called a smooth pipe. You can see on the very bottom of this chart. What is a smooth pipe? Smooth pipe actually means when the epsilon is equals to 0. So it's like very, very smooth, and you probably won't see those bumps on the wall of the pipe at all. But even though with the smooth pipe, you can tell the friction factor here cannot be zero. So it's not zero, which means there is always a head loss in any kind of pipe. Doesn't matter how smooth the surface is. Okay, so that's about the turbulent zone. I also want you to pay a little bit attention on this relative roughness factor here. So it's kind of a reverse order. So on the top of the chart, you see the smaller numbers, smaller relative roughness numbers, kind of shows some rougher um, um, pipe walls, and well, on the lower part of the chart and shows larger numbers and they actually representing smooth pipe walls. Talking about the pipe roughness values, the book gives us a small table, and this is on page 185, I believe. This table is very limited. You can see for some common materials of the pipe and the roughness number we can use. They're the design values we can use for our problems. Um, as I said, this is a very small table. You probably cannot find all kinds of materials here. And as a designer, you may also want to check with pipe manufacturers to get data from them. Okay, this is about the Moody diagram, and in my next video I'm going to give you an example showing how to use Moody diagram and also the equation we give you today in an example. Thank you very much, and have a good day. Bye now.